Very good morning, students. Unit-VII, Thermodynamics. Unit-VII, Thermodynamics. In this session, I am going to teach the second law of thermodynamics. Second law of thermodynamics. Okay. So, need for the second law of thermodynamics. Need for the second law of thermodynamics. So, already you know that first law of thermodynamics. The energy of universe is conserved. Okay, so the following two passes. So refer to the following two passes. The first one, the glass of hot water. The glass of hot water over time, so loses heat energy to the surrounding and it becomes cold. The glass of hot water over time loses heat energy to the surrounding and becomes cold. Okay, so the hot water taken in a glass tumbler. Okay, so after some time, the heat energy transferred from the hot source to surrounding. Are you right? So the second one, when you mix hydrochloric acid and sodium hydroxide. Hydrochloric acid and sodium hydroxide. It forms sodium chloride. So neutralization reactions. So sodium chloride and water. And water with the evolution of heat. The heat energy is released. This process is exothermic process. The neutralization process is exothermic process. Are you right? So heat energy is released in this process. Okay, in both the process, the total energy is conserved. The total energy is conserved. Are you right? So the two processes follow first law of thermodynamics. The total energy is conserved. However, the reverse process, the first one is the hot water is converted into cold water. In reverse process, the cold water becoming hot water by absorb heat from surrounding and its own. This process is not spontaneous process. The glass of hot water over time so loses heat energy to the surrounding and becomes cold. It's a spontaneous process. Spontaneous process. Okay, natural process. But in reverse process, the hot water, the cold water becoming hot water. Becoming hot water by absorb heat energy from surrounding. The process is non-spontaneous process. The reverse process is right. The reverse process is non-spontaneous process. Non-spontaneous process. Are you right? So the energy supply, the manually supply the energy in the reverse process. Are you right? So non-spontaneous process. Are you right? So the cold water becoming hot water from absorbed heat energy from manually supply. Okay, so non-spontaneous process. But the energy, right? The total energy is conserved. Both the process, the energy is conserved. The energy is conserved. So follow first law of thermodynamics. But is spontaneous process and reverse process is non-spontaneous process. In second one, the hydrochloric acid reacts with the sodium hydroxide to give sodium chloride and H2O. In reverse process, the solution of sodium chloride does not absorb heat energy in its own. However, the manually supplying of heat energy in this process cannot take place reversely. Cannot take place reversely. The preferred direction reaction. Preferred direction reaction. Are you right? So the solution of sodium chloride cannot change into hydrochloric acid and sodium hydroxide in observed external energy are also. Are you right? So the some process is spontaneous and some of the process is non-spontaneous and some of the process is preferred direction. Preferred direction. So in order to explain the feasibility of the process, we need the second law of thermodynamics. We need the second law of thermodynamics. Right? Okay, students. The various statements of the second law of thermodynamics. The various statements of the second law of thermodynamics. The second law of thermodynamics introduced the another state function. Another one, state function. State function entropy. The second law of thermodynamics introduced the another state function entropy. Right? Define entropy. Define entropy. The entropy is a measure of the molecular randomness. Entropy is a measure of the molecular randomness. Molecular disorder. The molecular disorder or randomness. Randomness of a system. So entropy is a measure of the molecular disorder or randomness of a system. Are you right? So the system, the reaction functioning area. Reaction area is a system in surrounding, right? So system and surrounding. The molecular disorder, the calcium carbonate is heated converted into calcium oxide and carbon dioxide. The calcium carbonate is disorder or randomness. The measure of the molecular disorder or randomness of the system. In all the natural process is a spontaneous process, its randomness is increases, the entropy are also increases. For example, the rusting of iron is a natural process. So iron rod, okay, so the strong metallic bond, but occur in rusting, the disorder of metallic bond. The metallic bond is disorder, okay, the randomness is started. The entropy are also increases. In all the spontaneous process, is a randomness process or disordered process. So increase the entropy. For example, the growth of man. So child to man and growth of tree, small tree to bigger trees. Okay, so the natural process, the randomness is increases. The entropy are also increases. In all the natural process. Okay, so this process is need not induced. Does not induce the process. So the natural process is randomness increases. The spontaneous process. So the entropy is increases. So entropy is a measure of the molecular disorder or randomness of a system. randomness of a system. In a thermodynamic definition of entropy change, thermodynamic definition of entropy change, ds, entropy symbol S. The entropy expressed S. So ds, the small change, or del S, entropy change. S2 minus S1. Okay, so after the disorder and before the disorder. Okay, so measure of the molecular disorder after the disorder and before the disorder, right? So del S, the del S is equal to the thermodynamic definition of the change of entropy is the ratio of the heat. The ratio of the heat evolved Q2 minus Q1. Okay, so Q2 is so after the randomness, Q1 is before the randomness of heat energy. The ratio of the heat evolved to the temperature of the process. Or del S is equal to del Q by T. Right? This expression or this relation varied only reversible process. Are you right? This relation varied only reversible process. Right? So the first statement, entropy statement. The first statement is entropy statement. The entropy of the isolated system. The entropy of an isolated system. The entropy of an isolated system increases. The entropy of an isolated system increases during a spontaneous process. Is an entropy statement. The entropy of an isolated system increases during a spontaneous process. In all natural processes, a spontaneous process. During a spontaneous process, the entropy of an isolated system increases. Are you right? All the natural process is spontaneous process. Alright? During a spontaneous process, the entropy of a system increases. Is a first entropy statement. Are you right? So, in a reversible process, the entropy change. The first is a reversible process or irreversible process. In an irreversible process, the spontaneous expansions of gaseous is a irreversible process. The rusting of iron process is a irreversible process. Right? In all the natural processes, irreversible process. The child grows to man, but man cannot reverse to child. It's a natural process. So all the natural processes, irreversible process. Okay, the del S entropy change total is equal to system and surrounding. So del S system plus del S surrounding. The del S total is equal to del S system plus del S surrounding. The total entropy change is equal to sum of the entropy change of the system and entropy change of the surrounding. Right? It's a irreversible process. Yeah? Irreversible process. It's a spontaneous process. It's a spontaneous process. In always del S total. Del S total is greater than 0. The entropy change always greater than 0 in irreversible process. So very, very important 1 mark questions. Very, very important 1 mark questions, right? So the irreversible process say always del S total greater than 0. In other words, del S universe, del S universe is equal to del S system plus del S surrounding. So del S system plus del S surrounding. So in irreversible process, the del S universe always greater than 0. Always greater than 0. Right? Is a reversible process. Next one, reversible process. The irreversible process, neutralization process. Acid base neutralization process are also irreversible process. The spontaneity is increases. The entropy are also increases. The second is a reversible process. A reversible process. So ice. Example, ice. A physical process. Ice is heated. Ice is heated to convert water. The water is cooled, then converted into ice. Are you right? So the ice is converted into water and water is converted into ice. So this process is a reversible process. This process is reversible process. So ice is converted into water. The entropy change is 10. For example, 10. The entropy value is 10. Water is converted into ice. So the reversible process, the entropy are also same, minus 10. Ice to water, the randomness increases. The randomness increases, the del S value is positive. The randomness increases, the entropy change value is positive. The randomness is decreases. Okay, so increase the randomness. Increase the randomness, del S value is positive. So the decrease the randomness. The decreases the randomness, the del S value is negative. So the ice converted into water, the randomness is increases in same time 10. So randomness del S value 10. So water is converted into ice, the decrease the randomness, so minus 10. So the del S universe. The del S universe is equal to del S system. Del S system plus del S surrounding. Del S surrounding. Okay, in a reversible process, the del S system is equal to minus del S surrounding. Alright, the del S system is equal to minus del S surrounding. Okay, so the randomness system to surrounding, the randomness increases 10, and surrounding to system, the randomness is decreases minus 10. Okay, the del S system is equal to minus del S surrounding. So the del S universe is equal to 0. Are you right? So very important. So irreversible process. In irreversible process, del S greater than 0. In irreversible process, del S greater than 0. Okay, in a reversible process, del S equal to 0. Del S equal to 0. Are you right? The system of universe, the entropy of universe. The entropy of universe is equal to S surrounding, S system plus S surrounding, S surrounding. Are you right? So the universe, the entropy of universe. The entropy of universe is equal to constant. Entropy of universe is constant. Right? No change in universe. Are you right? So, very important one more question. Students, listen. The first one, the entropy change of irreversible process greater than 0. The entropy change of reversible process equal to 0, equal to 0, the entropy of universe. The entropy of universe is constant. The entropy of universe is constant. Are you right? Okay, students, the next statement, Kelvin-Blanc statement. Kelvin-Blanc statement, it is impossible to construct a machine that absorbs heat from a hot source and converts it completely into work by a cyclic process without transferring a part of heat to a cold sink. Cold sink is a Kelvin-Blanc statement. It is impossible to construct a machine. It is impossible to construct a machine that absorbs heat from a hot source and converts it completely into work by a cyclic process without transferring a part of heat to a cold sink. And for example, cooker. So cooker is a complete cycle. Are you right? It's a cyclic process. It's a complete cyclic process. So taken in water, rice, salt. Okay, so close the cooker. So close the cooker is a complete circle. Are you right? So it is impossible to construct the machine that absorbs the heat from a hot source and converts it completely into work. The cooker absorbs heat from a gas stove. Are you right? The cooker absorbs heat from a gas stove. That heat energy completely converted into used cook only. How is possible? First, the absorbed heat transferred to cooker, the hot source cooker. Then the heat used to cook rice. Right? But it is impossible to construct the machine that absorbs the heat from a hot source and converts it completely into work by a cyclic process without transferring a part of heat to a cold sink. In another one example, iron box. Okay, so current supply the iron box, so cannot heat, does not heat in iron box, but iron in the cloth. How is possible? Some of the heat energy absorbed the iron box, then used to iron the cloth. So it is impossible to construct the machine that absorbs heat from a hot source and converts it completely into work by a cyclic process without transferring a part of heat to a cold sink. The efficiency of machine can never 100%. The efficiency of a machine can never 100% say any one of the machine. Are you right? For even an the efficiency of ideal fractionless engine can never 10%. So the scientist Carnot on his analysis of heat engines found that the maximum efficiency of a heat engine which operates reversibly depends only on the two temperatures between which it is operated. Are you right? Okay, understand students? So ஒரு அயன் பாக்ஸ் இருக்கு அப்படின்னா நம்ம அயன் பாக்ஸ் சுவிட்ச் ஆன் பண்ண உடனே அயன் பாக்ஸ் ஹீட் ஆகக்கூடாது, டைரக்டா அயன் பண்ணணும். How is possible? So first அயன் பாக்ஸ் ஹீட் ஆயிட்டு அப்புறமா தான் என்ன ஆகும், அயன் பண்ண முடியும். அப்ப எடுத்துக்கிற எனர்ஜிய கம்ப்ளீட்டா ஒர்க்கா மாற்றக்கூடிய எந்த ஒரு மெஷினுமே கன்ஸ்ட்ரக்ட் பண்ண முடியாது. This is a Kelvin Blanc state. Okay, so the efficiency eta is equal to the work performed by heat absorbed. The work performed by heat absorbed. Okay, so eta is equal to QH minus QC by QH. Okay, in other words, in always positive values. So the modulus of QH minus the modulus of QC divided by the modulus of QH. Modulus of QH. So QH is a heat absorbed. The heat absorbed from hot reservoir. H is a heat absorbed from the hot reservoir, and QC is a heat transfer. The heat transfer to cold reservoir. Heat transfer from cold reservoir, right? The heat absorbed from the hot reservoir and heat transfer to cold reservoir. Okay, so absorbed heat, the sum of the heat is transferred from cold reservoir, right? So it is eta is equal to QH minus QC divided by QH. In a reversible process, in a reversible cyclic process. In a reversible cyclic process, the del S universe is equal to del S system plus del S surrounding. In a reversible cyclic process, the del S system is equal to minus del S surrounding. Already you know that in a reversible process, the del S system is equal to minus del S surrounding. Right? So the del S is equal to del Q by T, right? The entropy change is equal to the heat change divided by temperature. Are you right? So the QH heat absorbed from the hot reservoir divided by TH is equal to the QC divided by TC. The heat transfer to cold reservoir by cold reservoir temperature. Hot reservoir heat, hot reservoir temperature, cold reservoir heat and cold reservoir temperature. Cold reservoir temperature. Are you right? So, in a reversible process, del S system equal to minus del S surrounding. So, system and surrounding. So, system positive, surrounding negative. Right? So, minus. Right? Del S system is equal to minus del S surrounding. So, del S system is del S surrounding. So, del H, QH by TH is equal to minus QC by TC. So, therefore, the TC by TH is equal to minus QC by QH. So, both are equal. Right? In other words, the modulus of QC divided by the modulus of QH is equal to TC by TH. The modulus of QC by QH, okay, that is equal to 1 minus QC, modulus of QC divided by modulus of QH. So both are equal. So 1 minus modulus of QC by modulus of QH. The value of modulus of QC by QH is equal to TC by TH. Therefore, the efficiency neta is equal to 1 minus TC by TH. 1 minus TC by TH. Right? The percentage of efficiency. The percentage of efficiency neta is equal to. The percentage of efficiency neta is equal to 1 minus TC by TH into 100. 1 minus TC by TH into 100. Right? The modulus of QC by QH is equal to TC by TH. So 1 minus QC by QH is equal to TC by TH. 1 minus TC by TH. The efficiency of neta is equal to 1 minus, the 100% efficiency of neta is equal to 1 minus TC by TH into 100. In always, the TH is more or greater than TC. The heat observed from a hot reservoir is greater than the heat transferred to cold reservoir. The temperature of observed hot reservoir is more or greater than the transfer of cold. The temperature of transfer of cold reservoir is lesser. Okay, so greater is lesser. And always in all the engine. Right? So the percentage of efficiency, the efficiency always less than 1. The efficiency always less than 1. In percentage of efficiency always less than 100. The efficiency of the machine can never send percentage. The efficiency of the machine can never send percentage. So percentage of efficiency always less than 100. So very, very important 1 mark questions. Right? So the third statement, class S statement. Okay, so next the third statement, class A statement. The third statement, class A statement. So right, it is impossible to transfer. It is impossible to transfer heat. It is impossible to transfer heat from a cold reservoir. Cold reservoir to a hot reservoir without doing some work. Without doing some work. Without doing some work. Okay, so class A statement. It is impossible to transfer heat from a cold reservoir to a hot reservoir without doing some work. You right? So already you know that in steam bath, how is taken in steam bath? Okay, so the hot water mixed with cold water. Right? So hot water mixed with cold water, the heat energy transfer from hot water to cold water. It's a spontaneous process. So need not induce this process. So the heat energy is converted into from hot water to cold water in steam bath purpose. Okay, but it is impossible to transfer heat. It is impossible to transfer heat from a cold reservoir to hot reservoir without doing some work. So without doing some work, எந்த ஒர்க்கும் செய்யாம நீங்க cold reservoirல இருந்து hot reservoirக்கு heat energy change பண்ணுங்க. But hot reservoir இருந்து cold reservoirக்கு spontaneous process, automatically heat energy high ல இருந்து low நோக்கி transfer ஆகும். But cold ல இருந்து hot க்கு மாத்தணும் அப்படினா ஏதாவது work பண்ணாதான் அது நடக்கும். So அததான் சொல்றோம். It is impossible to transfer heat from a cold reservoir to a hot reservoir without doing some work. இதுதான் நமக்கு தெரியுமே சார் அப்படின்னு நினைச்சாங்க. இதெல்லாம் ஆரம்பத்திலே thermodynamics introduce பண்ணும்போது இந்த விஷயங்கள்லாம் சொன்னதனால தான் இப்போ நமக்கு இதெல்லாம் தெரியும். Right? So the unit of entropy. Next, the unit of entropy. Unit of entropy, right? The unit of entropy. The entropy del S is equal to del Q by T. The ratio of heat evolved to the temperature of the process. The exchange of heat exchange divided by temperature. So heat exchange Joule mole inverse, temperature Kelvin. The SI unit of entropy change is equal to Joule Kelvin inverse mole inverse. Joule Kelvin inverse mole inverse. Right? So the SI unit of entropy Joule Kelvin inverse mole inverse. Right? Okay students, the example problem. If an automobile engine burns petrol at a temperature of 170 degrees Celsius, and if the surrounding temperature is 27 degrees Celsius, calculate its maximum possible efficiency. Calculate the maximum possible efficiency. So given the temperature of the automobile engine burns petrol at a temperature of 127 degrees Celsius. So TH is equal to 127 degrees Celsius. In chemistry, does not use in degrees Celsius, so converted into Kelvin. In all the problem, okay. So chemistry in all the problem, degree Celsius is converted into Kelvin. So very important. So plus 273 Kelvin. So that is equal to 7 plus 3, 10. Remaining 1, 8 plus 2, 10. So remaining 1, 3 plus 1, 4. 400 Kelvin. So dH is equal to 400 Kelvin. And Tc, the surrounding temperature Tc is equal to 27 degrees Celsius plus 273 Kelvin. That is equal to 7 plus 3, 10. Right? 8 plus 2, 10. So remaining 1, 3. 300 Kelvin. Okay. So therefore, the efficiency, the percentage efficiency, eta is equal to 1 minus Tc by Th into 100. 1 minus Tc by Th into 100. That is equal to 1 minus 300. 1 minus 300 by 400 into 100. That is equal to 400 minus 300 divided by 400 into 100. That is equal to 100 minus 400 minus 300, 100. 100 by 400 into 100. That is equal to 1 by 4. 1 by 4 into 100. Right? That is equal to 100 by 4 is equal to 25%. 25%. Right? So the maximum possible efficiency is equal to 25%. Right? Okay, students. Thank you, students. We'll meet next class.